Just as an introduction, I run cloud products within HYCU. So any workload that touches any three hyperscalers, I have portfolio coverage over. And I'm in year two at HYCU as well. Come from the world of protecting Kubernetes and a lot of the infrastructure elements that power AI today as well. I know very often when people talk about AI, there is a lot of importance given to the shovels, the GPUs, the models, but not a lot of conversations happen on the data that actually drives the intelligence for AI, right? So our goal today is to kind of explore, how data protection needs to evolve um, in the age of AI, and how do we protect the data sets that are being generated both by AI and for AI um, these days, right? And also all the infrastructure that gets put in place to make AI possible for a lot of the organizations, and how today cloud is the default delivery model for a lot of AI in many organizations. So as we talked about, let's start with cloud. I call it the home of AI these days, right? This is where very often people start when they start their AI initiatives. Cloud providers have more access to GPUs than an average enterprise in the market, and you get the bursty compute you need for a lot of the model work that you are doing within the organizations, right? So cloud has become the home of AI. But with cloud, there is a whole bunch of problems that exist when it comes to data protection, right? We call them the silent killers. We call them the lifestyle diseases with this data set, right? You have too many applications. You have too many as a service elements that are kind of put together to drive your pipeline. And that creates a lot of the console chaos. You have to use multiple consoles to manage, what's happening with your pipeline, right? And that also creates a lot of API and automation sprawl. And the other part of it, there is a lot of data being generated, but there is not a lot of efficiency built into the cloud. And again, cloud isn't compensated for driving a whole bunch of efficiency in terms of how you store that data, right? So we're also seeing that there is this obesity when it comes to the amount of data that you're storing, within your infrastructure and within your tenants. And despite all of this, there are still blind spots when it comes to AI and AI services. There is a large number of services being built in all of these cloud providers to make AI possible, but the data protection vendors haven't really kept up with all that data set. And even being able to serve that data back to the customer in an AI friendly fashion, that's not really possible today with a lot of the solutions and what we're looking to solve with HYCU.
That's
What you
Sathya?
Yeah.
Hi, Guy Courier with Futurum here. Can you talk a little bit more about this first one, fragmentation? One of the big drivers, I think, towards data lakes has to do with avoiding this by just having a simple way to throw everything in a single bucket. And that alone, I feel like a sort of typical data lake or data lakehouse vendor would say that solves this, because that provides you with a single console. Maybe it creates the challenge of all the chaos having to be reached out to pull everything in. But how would you respond to that?
Yeah, look, it's a great question. And in a couple of 2 or 3 slides down the road, we actually walk you through what a typical stack looks like.
I knew that actually, so please continue.
Right. So, in what you do see is the lakehouses, which we'll spend a lot of time today talking about, are becoming the unified platform in many ways. Right. It is doing more and more unification. It's multimodal. It's versatile. You can do both. Optimize for both storage and analytics. All of that is true. But it is not true that today's data pipeline stores primarily in those workloads. It is, again, even if it is primarily, you need to preserve meaning when you're protecting AI data sets. There is a lot of data that sits around these data lake houses that needs to be protected as well to protect your full infrastructure. Again, great question, and thank you for that. In a couple of slides, we'll actually show you what a sample AI data stack looks like and why that kind of coverage and for that fragmented workload matters.
Well, in my opinion, I'm actually following with my fellow delegate, Keith Townsend here, his guidance on this. It also does create a problem of its own because of data gravity. The more you collect data, however processed or managed in one place, the stickier it can be there even, that
Yeah.
really hasn't been solved.
Yeah, the good thing is, as we are in the world of providing insurance for that data, right? And when data gravity shifts, it's our job and responsibility to kind of shift along with that and build our applications to make sure that data gets protected. And I think we are seeing that with the cloud, where the object storage is perhaps now the landing spot for a lot of the data sets, and the lake houses are the new systems of records. So between object storage and lake houses, you're seeing more and more data sets kind of landing in the cloud. And that means more and more applications and the processes and those things will also have to be built in the cloud, because again, the data is going to pull you where the data is. Uh, right. And we certainly see that, and why we think cloud is the new home of, I mean, it's not the new home, it is the home of AI, because again, lots of customers' data is being stored in those lake houses and object storage in general, right? And talking about cloud, one of the things that Haiku is really, really good at is this coverage. And we talk about insurance industry and data insurance industry. Everybody knows coverage is currency for us, right? How many workloads can you protect? And I'm using, I mean, each of these cloud providers is now offering over 100 to 200 services for a variety of things that the customer wants to do. How do you keep up with these growing set of diversification of your data sets? What used to be within four walls of your data center is now just spread everywhere, right? And how do you protect your data sets in this context? And one of the things IQ is really good at is the coverage matrix. We have protect over 90 plus workloads today, and we already have the broadest coverage when it comes to cloud in terms of the number of workloads we protect in the cloud, right? And so let's talk about how AI changes the game a bit in the cloud, and how a lot of our strengths kind of carry over in this context. As you know, AI is not just, I mean, this delegate clearly knows that AI is not just about ChatGPT and your interactions with the chat platform, right? And there is so much that is happening in the back end when it comes to what an AI effort entails in an organization. You start with ingesting training data sets and actually creating training data sets. One of the things that we're learning is there is a huge increase in spike in storage and storage around data lake houses as well as object storage, because everybody's creating one additional copy of all their data sets to kind of feed AI to drive those insights, right? People didn't have a centralized repository of all their data sets in one place. Now AI is kind of pushing you to create that set of training data sets, right? But raw data set doesn't actually get the job done, or doesn't doesn't optimize for those model training. You do have to enrich the data and make the data look friendly to AI so that it's easier for AI to ingest. There's a lot of enrichment that happens, and then you go through training. It's multiple runs, and at each point you're creating weights, you're creating logs, you create a lot of the tunability that happens in that case, and then you finally kind of serve that to your users, and then there is a full feedback loop in terms of just making that again part of what you learn from in general. The key thing to note is uh, this is AI implementation in a lot of organization is a relay race, right? The baton gets passed from one to another to actually drive the outcomes you need in the organization. And if losing the baton once, in this relay race, you kind of break the traceability in AI or the trust in AI. And this is really where the challenge is when it comes to data protection. if you don't follow this relay race and ensure the baton gets passed around from one to the other, and you're fully capturing that particular race, you're not really in the race in that context, right?
So
Um,
the quick question on, because there's several, this is Keith Townsend, the advisory bench. There's several challenges around data protection as you hand off from one process to another. And the challenge is not just protecting the data, but the transformation. So let's, focus on a RAG process that ingests the data, however we're getting it. And then we go to enrich the data for AI, whether that's serving up via inference or we're serving it up for training. A lot of the mistakes happen at this level, and the visibility of being able to trace back the issue and revert back to state is a legitimate challenge. Are you guys helping with that problem or just the ability to recover the underlying data set?
yeah, look, for each of those service, like for example, if you are storing your vector databases uh, in AlloyDB as an example in Google Cloud, right? What we do have is the ability to capture that state, kind of bring that back to the state. One of your model runs amok, and it's not the data set you want, and a lot of filtering happens in again AI model training as well. You have a data set that is potentially poisoned, right? In all of those cases, we do allow you to kind of bring back to a state where your previous models ran from potentially, right? So we make that possible to be able to restore back to an earlier state, but a lot of the times it's also about restoring the data in a format that AI itself can understand as well. So it's about being able to bring back the states, but also being able to produce that data back for future analysis to see if there was a problem with it, right?
Yeah, so for a case in point, like if I'm enriching the data with JSON so that it's better injected into my data pipeline for my vector database process, what happens 2 or 3 revisions down the line, I discovered that a edit that I made to the JSON structure actually broke something else, and reverting back to that clean state is not simple.
Yeah. Yeah. Schema drift, pipeline corruption, all of these are legit problems. And the good thing about HYCU is you can go back to an earlier state, but you can also produce an offline copy of the data you already had so that you can understand what went wrong. So both those elements are supported and enabled through HYCU.
So Satya, this is Ray Lucchese, Silverton Consulting. Do you plug into the checkpointing process during training? Data protection historically has been driven on a time basis or a change basis or something like that. I'm just trying to figure out where you play in training checkpointing.
Yeah, it's not so much that we plug into checkpoints, but it is a natural point for you to take your backups, right? A checkpoint is usually integrating with your backup application to make sure that, hey, I have this model checkpoint. I've stored all the, sampling weights and all of my metrics around my model implementation that's been stored in the registry. And that is a perfect time to kick off a backup so that you have um, all the data up until the checkpoint. So whether you're rerunning your models as a new run, or whether you're taking a checkpoint to make sure that I have this state captured, that's when they plug in with backup solution to make sure all these services that make the checkpoint protected as well.
So if I have, and that's not necessarily a bad thing. That's just if I have a custom data pipeline, just as long as you're storing the metadata that I need to do the recovery that I need, and this you're working with a sophisticated group. This is different than enterprise IT backup. This is usually someone working specifically with data pipeline, and they're going to have specific requirements around how they recover and what they're recovering within the data. So it'll be interesting on the kind of the brick level what I'm able to recover in this environment versus what I'd be traditionally looking at in HYCU's traditional type of customer.
So just to jump in here, this is Dave Graham from ML Commons. So what moved to asynchronous checkpointing, where you're in the entirety of your workflow is driven, in a different direction, where checkpoints aren't just fixed points in time anymore. There's something that is streamed. How does this obviate some of what you were talking about? Because there is no return to zero anymore. There is an ongoing process. You're ongoing and you're flowing through these models and through these training epochs in a different sort of way. So your return to zero, your return to a known good becomes
Last best state.
yeah, it becomes a little bit more ephemeral than it ever was before, right? So I think it was Carl that might have brought it up before, but you can act on a checkpoint file, 80 gigs plus whatever, or whatever dump comes out of that. But how are you integrating above that stack then into the command and control center of that training system or whatever ends up being used, whether it be CUDA or otherwise?
Metadata to control where you will
Well,
left
yeah,
off and stuff like that.
This becomes the Hydra problem, right? There's so many different aspects of things that you would want to control. Because a lot of those checkpoint files are just there. It's garbage anyway in the end, right? It's just there for, cover your ass type moments. Right? The metadata ends up becoming the driving point. Yeah, you want to make sure you maintain that. So anyway, so
from a practical problem, I've run into this. So I've transformed my data, but I need to recover not the entire state. Your comment of returning to zero. I'm not trying to return to zero. I want to save the work that I've done up to this point and return a portion of my data pipeline to its original or to a different version of the state. I don't know how to solve that problem. If you guys are solving the problem, that is really interesting.
well, if you have an entire NVL72 that's chunking away at this stuff, you're going to return to a known good state. You're going to now have to pull 72 GPUs back to a known good state to recalculate that epoch, right? That's a big lift if you're going to try to do that. So consistency wise, again, and it's not, I think the idea here is noble. Absolutely. I'm more curious to how do you now embed yourself into a process that is literally changing week on week as we discuss these technologies.
Yeah, and what's really cool to hear is, what you are talking about in terms of being able to go back to last good state and so on. This is what backup vendors have been doing for years for any data set, right? Any data set that we protect is always changing. Any data set that we recover is because we need to go back to a known good spot in majority of the cases, whether it's because of disaster, whether it's because of cyber attacks, whatever the reason may be, we go back. In this case, it's because of experimentation, right? So at the end of the day, we capture state and we allow you to go back to state. And when it comes to capturing state, we'll also talk about how you capture that state in a more consistent fashion. And that's also things that we're investing in and have actually built some patent pending technology around how do you drive consistency among the data sets that you're actually protecting, so that when you come back, it's not going to look at the data set that just came back as, hey, what is this that I don't recognize, right? You need to be able to put back and expect things to run normally. And there is a lot of work to be done. We're not saying that we've solved every problem there, but we have solved some problems that are, very key, and we'll walk you through those consistency element as well when we go through the solution in more detail, right? So again, the point is lots of living data sets.
Yeah.
So lots of living data sets being produced. And again, those data sets need to be protected. You drop the baton once, you kind of lose a lot of the traceability and trust, that AI generates. You don't want to be producing results later saying, hey, we don't know why my models behave the way they behave. You need to be able to, again, trace back and say what actually happened. To an earlier question that came up, let's take the example of a customer building an AI pipeline in Google Cloud, right? You start with a workbench that has direct integration into GitHub and BigQuery and so on. You deal with your training data sets. You create your feature data sets where your digital twins are stored. You create prediction data sets with both what you send inside and what it comes out of it. And you generate a lot of model artifacts in Vertex AI pipelines, right? So what you see is data set is sprawled across multiple services. People use the best of breed solutions for each of this data set. Yes, you're going to see BigQuery, which is the lakehouse platform that Google has, right? You see this in multiple columns. And to an earlier comment, yes, lakehouses are becoming that unified central platform, and we're really happy about it. But you're also seeing that it's not the only platform people use. At the end of the day, BigQuery can't be your workbench. BigQuery can't be where you store your source codes. And it is not the best platform for real-time insights or feature data in general. So there is a lot of cloud elements that customers use to be able to create an AI pipeline. And what we are doing is to ensure protection across all of these services with HYCU, so that more and more of your AI infrastructure is covered, protected, and you have confidence in those capabilities. Right? So, and that's why this graph where we talk about all of our coverage matters, because you want to be able to capture everything from VMs, which could be your workbench, all the way to vector embeddings, right? So all of that data needs to be protected, and why our coverage really matters in this context, right? And let's talk lake houses, right? And again, glad that group is already tuned in and kind of see this change happening like we see it as well. Lake houses, I like to call this, they are kind of bringing together AI, BI, and what I call CI, right? The continuous insight for an organization, right? So the lake houses are becoming the new system of record, and it is growing at a phenomenal pace in customer organization. We've worked with customers, who said they have a near 100% growth year over year on some of their lakehouse data sets. And these are not 100% growth when they are 70 GB. They are 100% growth when they are at 700 terabytes, right? They're talking about a massive growth even at scale. And why you're seeing lakehouse platforms like BigQuery and Databricks and Snowflake, each multi-billion-dollar businesses, they're all around $3 to $5 billion businesses on their own, but each of them growing at nearly 50% year over year. They're creating a nearly a $2 billion business every year and kind of adding to their balance sheet at this point. And that's because, again, customers are adopting lake houses, that single unified platform where they can store all this data set, right? And as we talked about, that creates gravity. When more and more data set lands in a specific platform, you start building solutions that protect that particular platform, that deals well with that particular platform, and integrates first-party integration into some of these lakehouse architectures with a lot of solutions that are built around these data sets, right?
Sathya,
And we are,
can I interrupt and ask you a question on this?
yeah, please do.
So from your customer interaction, Scott Robon with Solutional, it seems like there's a spread of very mature customers who are really disciplined and have gravity in one place, but a very long tail and continuum of customers that don't, and maybe will never need to. Where do you work best on that spectrum? Because like when you say lake house, it's like, well, I have a place at the lake, but I also have a place at the beach, and I've got a place in the mountains where there's streams, not lakes or oceans. And I think that's more a real representation of where many enterprises are today.
Yeah, and you're true. The workload, the customer environments are often on both ends of the spectrum, right? You have a very long tail in this curve. You have a whole bunch of customers who have data sets that are kind of spread everywhere, and you've got a lot of customers who are also going through consolidation of all that data set into a single platform, so they could drive outcomes, their AI outcomes, a lot faster, right? And the good thing about our solution is that we were already built for the customers that had data everywhere.
Okay.
Right? We had 90 plus workloads already supported, right? whether you keep your CRM data in Salesforce and GitHub data, your source codes in GitHub, and your databases in Cloud SQL, it didn't really matter. We provided support for all of those workloads individually through a platform What we are seeing now is not just a group of customers that have data everywhere, but also a group of customers who are consolidating and creating these massive data sets that are feeding into AI. And that's the journey we're seeing. And we want to be there to support those customers who are doing that on this front as well, because these are workloads that have not historically been talked about in the context of data protection, right? Backup vendors didn't talk about BigQuery. Backup vendors didn't talk about Databricks, and still don't. And we're seeing that shift and are adapting our solutions to kind of become the best in breed for those workloads as well.
Okay.
Okay. In the thing that I also want to highlight is, this data set is, yes, it's special. It can handle scale, but there is also potential for data loss in this context. We talked about a couple of scenarios already. I think Keith mentioned, hey, I could have a corrupted JSON file completely screwing up my models. And that's certainly possible. Schema drift is a consistent problem where models break. You can also have poison data sets. I mean, the first thing I hear from cloud vendors when they talk about these, BigQuery and Databricks and so on, they say, hey, we don't give you access to a compute. Somebody can't just come in and run, corrupt your data set there. But what you do give is access to APIs. And with those APIs, you could poison data sets that your models are being trained on. And that could be the face of AI in this model. But whatever is the issue, we do need to understand that any data, any service has chances of going wrong. You could lose them, and you want to have the ability to go back and protect them. And that's one of the key elements to really think through. Again, our job is to kind of follow where the data is going. We're seeing that the data is going to these lakehouses and object storage, predominantly in the context of AI. And we want to make sure that we have the best in class solution. So you could get back those data sets if you ever need for whatever reason that is.
Just saying you should update that
Don't
lab
have
to
that.
include Amazon. Because US East going down is kind of legendary at this point. Might as well make them notice.
Yeah, and look, I think pointing that out is a little bit of like ambulance chasing as well. But in this context, and absolutely, and we'll talk about why that problem also is permeated across all these enterprises, is because AI is the cloud is the home of AI, but cloud is also puts a lot of people under house arrest, right? And people don't really have a way to create that cross cloud resilience across these data sets. So yes, it's your home, but you're also under arrest to some extent, and that again needs to change. And you'll see that we have some solutions that helps provide that cross cloud resilience and shareability of data set from one cloud provider to another as well. This is just to show that uh, data recreation, if you lost your data sets, is very expensive. Yes, it's possible. It's possible in some cases. I'll explain a scenario where it's not possible. But generally, when it's possible, if you had infinite time, infinite resources, and infinite APIs, of course, you can build a lot of that data set back. Very often, what sits in lakehouses is your second copy of a data set. It's already sitting someplace else, and you need to transform that and store that in a lakehouse before you feed it to AI. So one of the reasons people don't think about backups immediately. But what we're also seeing is these lakehouses are really good at streaming data, right? And customers are feeding, whether it's for sentimental analysis based on Twitter messages, right, or any social media messages that may be, or AI, I mean, IoT data sets and sensor data sets that are coming in from multiple places. Those data sets are getting streamed directly into these lakehouses, So it's your only copy of data sets there. And if you lose them, the sensor is not going to regenerate those information for you. And Twitter is not going to give you back all of those old tweets without charging you for, a spike in API usage, right? I think at this point, what they charge almost 500K a year to search through and collect about 50,000 tweets. And that's the kind of plan you're going to be paying for in Salesforce as well. Right? So what we deliver to this ecosystem, we talked about why it's important. We talked about what it would cost to bring back the data set if you didn't have a reliable mechanism. And now I want to kind of talk about what we do for this data set, right? And the key thing to highlight is we don't want to be just the FedEx that takes data from point A and store it in a different spot, right? We're not just trying to move data blindly from point A to point B. One of the things that we want to do when you protect AI is not just protect the raw data behind that, but also protect the meaning, protect the intelligence that feeds into uh, these pipelines. So when, for example, you protect a table, a raw data set that you're trying to protect, what HYCU does is that it has the mechanism to capture not just the raw data sets, but also the views, the models, the routines, the access policies, the schema. So we are protecting all of that data set and not just your raw tables that are coming in. Again, a lot of the times you can get the raw table out and you get the raw table in, but if you don't know how that raw table is processed, and then you don't have good visibility into that data set, why I think we're extending beyond just protecting raw data set, but also everything that kind of sits around it, the views, the models, and the routines, and so on. And there was a question on, hey, consistency, right? In workloads like data lakehouses, take BigQuery as an example, right? People store data sets, the data, it could be a couple of petabytes of data set, but they're being stored in smaller and smaller chunks. There is partitioning, and people store with different data sets. What that means is when you're taking a backup of a data set, and you kick off an export or a backup, you may get to data set 1 at 11 a.m. in the morning, and you get to data set 35 at 12:30 in the afternoon, and you get to data set 200 at 5 p.m. in the evening, right? So you're actually protecting these data sets at very different times. So one at 11, one at 1:30, one at 5 p.m. Then how do you drive consistency? How do we make sure they're all saying the same thing? They're all referring to the same state. What we do is deliver atomicity in this context. We line up these data sets as it look like at a certain point in time. A lot of these solutions offer what is called time travel that allows you to go back to any point in time over the last 7 days. We actually tap into that and leverage that to say, hey, line up all of your data sets to make sure that it look like from a common reference point, at say 11 a.m. in the morning, and then back up all of those data sets as it looked at 11 a.m. So even though we backed it up and we moved those data sets at 5 p.m., they all look like how it was at the same time together. And how we drive consistency is something that we have a patent pending on, and what we're driving with these data sets in this context.
Hey, Satya,
And
this is Ray Lucchese, Silverton Consulting. Don't most of these lake houses have internal backup procedures or processes? You just turn on a flag that and they automatically back up your data for you, and you don't necessarily need to do anything else. I mean, and all these guys is based on the cloud, which also has backup capabilities built in the underlying storage capability. So I'm just trying to understand the need for a solution like HYCU to come on top of these things.
yeah, Ray, what you say is really what a lot of people believe, but not what is right. Uh, right? In the sense that, yes, if you take BigQuery as an example, yes, it comes with time travel that you can configure And you have anywhere from 2 days to 7 days where you could roll back to a point in time. It's very fast. It's awesome. It's the technology that, every time I work with it puts a smile on your face, right? But your detection window in this context is 7 days. If you find a problem within 7 days, yes, you can go back to it almost instantaneously, and the solution makes it possible. But tell me, in the world of data protection, how many workloads have a 7-day data retention, right? Very few. You go to any company, ask them, what is your corporate policy for backups? It's 30 days, 60 days, 90 days. And some of them will say even 3 years and 5 years, depending on whether they are a regulated environment, right? If you're subject to NYDFS, you're going to be storing the data for a lot longer period. If you're subject to DORA, you want to make sure that that copy of data set that has customer data is at least stored in another location that is completely independent, right? These are all regulations that are in place for good reasons. And when you have all of your data set in one place and you're leveraging co-located copies for data protection, when someone gets access to that IAM boundary, you basically can get rid of both your primary copy and your secondary copy, and your detection window for recovering from that event is measured in days and not in.
Don't get me wrong. I understand the need for independent copies of data outside of the co-located solutions that are available. But I thought even that was something that many of the cloud providers supply.
Yeah. So when a cloud provider, none of the cloud providers, especially for this type of workload, I've spoken with a couple of these product teams, they don't want to be in the backup business, right? But if you want to dump a copy of it sometime once, they will allow you, and there are APIs to do that. But you are talking about a 2 petabyte data set with no way to generate an incremental storage or a copy, right? And I'll actually show that in example in the back end. What the cloud vendors offer is a way to keep a copy of it someplace, but they don't, like, for example, if you had immutability turned on those buckets, you cannot actually back up to those buckets today. You have an example where they're again only supporting raw data to be moved, not protecting your ML workloads, your access policies, and so on, right? So what they offer is very primitive, and often still locks you into the same platform, right? You can only export my warehouse data to my object storage because I've got a petabit network in between them. So I will only let the hop go into my own storage. I will not let you export into another cloud bucket. And those are all things that we can help address for a customer.
I gotcha. Thanks.
So, and that kind of leads to the next section, which is to say, the protection of these data sets, when you're talking 2 petabytes and 20 petabytes and 10 petabytes type data set, protection itself becomes cost prohibitive. It is no longer a thing that kind of hides behind in the budget. If you are creating multiple copies of your data sets and they are petabyte in scale, backup sometimes becomes cost prohibitive, and why customers kind of run with it, even though they understand shared responsibility model, oftentimes they realize, well, it's just cost prohibitive for me to do it, and I'm measured on my cloud spend, so I can't spend money on this, right? And that is a real thing we see in some of our customers. And what you see with the customer is, hey, I want an offline copy, and these are large data sets, so I want to be able to store it kind of incrementally. I don't want cyber resilience exposure. I don't want to land up in New York Times or Wall Street Journal because I didn't even do a backup. Like, I didn't even do basic backup of my data set. It's not like you can't foresee cyber attacks anymore. I mean, it's the new reality. Everybody's got to design a solution around the possibility of being attacked at some point. But there are limitations that exist in these platforms for these customers. You do have to make sure that you can actually egress out of where you are today if you want that cross-cloud resilience. Okay? So take our example and a real-world example. If you're generating 100 terabytes a day, being able to move that data as a full base copy every day, which is what these cloud providers offer you every day, and pushing it into an object storage, you take 30 days, 60 days, 90 days, you could see this 100 terabytes quickly become petabytes and a big line item in your budget, right? And they still can't back up to an immutable bucket. Recovery is slow. You're only getting a raw table and not everything that sits around those raw tables. Those problems still remain. It's still freaking expensive, right? So where we come into the picture, and it's also a partnership that we have in the ecosystem, is HYCU works with what people used to take for granted, deduplication, right? In on-prem world, people took compression, deduplication, and all of these things as granted because it was just available. Almost every organization had some form of data domain installed, irrespective of what backup application you had. And a lot of backup applications also offered, on-prem appliances that delivered deduplication. We kind of take that and we partnered with Dell in this context to drive deduplication in the cloud. So we work with Data Domain Virtual Appliance. They are the #1 storage target for backups. We work with them and we leverage their DD Boost protocol to say, take these lakehouse data sets, take the 100 terabytes of data that they are sending us, leverage DD Boost protocol to actually only ship the changes that the system thinks it needs. Because a lot of these are append only data sets. If you're creating a new base copy every day, you don't really need to store all that much data. You only need to store what changed between yesterday and today. And so that deduplication is something that we're offering. And we're actually seeing customers get up to 40:1 space savings because, again, you keep getting the same data again and again from cloud providers. But when we store it, we store only the fragments that have changed in formats that are very deduplication friendly, like Parquet formats. And that allows us to deliver both mobility for this data set and real protection for these data sets. And if you also take into account that we can replicate this data set from one cloud provider to another cloud provider post deduplication, you're not only going to save 40:1 in terms of your backup storage, you're also going to save 40:1 when it comes to egress charges. So you can actually store some of your golden data sets, highly curated data sets from one cloud provider to another cloud provider, because again, you can have a cloud provider failure. Like someone mentioned earlier, there was a recent incident. There's also an incident where $150 billion company in Australia was literally wiped from cloud infrastructure. Their account was deleted and their data was irretrievable. This is not a small mom and pop shop. This is $150 billion business in Australia that just woke up one day and found their entire cloud account was lost.
So,
How did they get back to this business?
Satya,
Was there a question?
this is Keith Townsend, the advisor bench. From a practical perspective, one of the challenges that, as I was hearing you're answering a question I'm glad I didn't ask earlier, which is the data gravity problem that Guy was talking about. So, this isn't workload management. I can't magically move, my large data lake from GCP into AWS because I want to use Bedrock against it. Before this, now, if you're saying I can get 40:1 dedupe, and now I can move my data out of Google into AWS. This is to use Bedrock against it because I have some business process in which I want to do that. That you're saying that HYCU helps me with that data gravity problem because of the dedupe capability.
Correct. But it does help you from data gravity problem, and it does help you from getting that cross cloud resilience. You don't have to feel like you're under house arrest.
But
Can
in those cases, if you want to move the data from Google to AWS deduplicated, you have to have a data domain appliance in both locations.
correct. And data domain is essentially running on top of object storage in each platforms. It is capable of running in all three hyperscalers. So it is replicating and reading deduplicated data that is then served back wherever you need them to be.
Yeah, I'm sure that's still going to be cheaper than
Moving
moving a petabyte of data. Data domain is going to be cheaper than doing.
Yeah, and especially considering that egress charges from one cloud to another cloud provider is 5 times the cost of storage. So you really think about in terms of dollar value, you're getting 40:1 in storage. You're actually getting 200:1 in savings when it comes to egress if you're trying to move from point A to point B. I'm not saying every customer is doing that today, but what this integration makes is it makes it possible for you to not store all your data set in one cloud provider and hope and pray that they've got everything together, right? And this will be something that you drive resilience in another place. It also provides cross. You can use the best of tools available in either cloud platforms on the data sets that you really care most about, right? Um, so that kind of wraps up at least my section before I hand it over to Subia, right?
Yeah.
The idea here is these are real challenges in the cloud. I mean, there were already problems in the cloud, but in the world of AI, it gets exacerbated. And what we have built with our solution is to really centralize the management of all of these services that people deploy for AI and deliver protection to one place, and actually provide coverage for a lot of workloads that act as blind spots in the industry today. Provide backup coverage for DBaaS workloads, provide backup coverage for data lakes and lakehouses, and do it in a fashion where it's efficient and lean so that you can actually deliver that kind of resilience we've talked about. So hopefully, again, a lot of AI work going on. We're super excited to become the home of your AI resilience, and really looking forward to working with our customers, seeing where the industry is going, and adapt our backup and cloud technologies to where AI is taking us. And that said, we talked about VMs to vector embeddings. Like, we need to be able to protect everything from VMs. This is where we all started from, to now thinking about vector embeddings. And Subia will walk through some of our key capabilities around vector databases and what we're doing there as well, and as well as the SaaS workloads and how we're adapting to the age of SaaS as well.
So I do have a question for you. This is Frederick Van Haren, Hyphens Consulting. So how fast does the deduplication work? So for example, if you have a new batch of data, at what point or how fast can you figure out if the data can be duplicated or not?
Yeah, there are two elements to the way we implement our data protection. One is when we transport the data itself, we diversify where the deduplication happens, right? So when we transport the data itself, we match checksums to make sure that we don't send the same data again and again. So a lot of network acceleration mechanisms that you've probably seen in the past, very similar. We use checksumming to make sure we don't even send the data that we know is already there, right? On top of that, data domain does its own um, process to make sure that, hey, if I find unique shards, then I keep just those unique shards and not keep any more of those data sets. It has got the intelligence to compress and deduplicate even further, but it only does that on the 5% of data that we think is really unique, and not on the 100% of data that we need to send and then make it do the work, right? So the combination of the DD boost logic, which diversifies where deduplication happens, but also a combination of what data domain does really, really well, which is really shrinking it down to just the bits you need.